Everybody, so here is vector word problems day 1, and we did problem number 1 together. So what I'd like you to do is to, if you don't know how to do that one, go back and watch the Google Meet video for problem number 1, as we're going to do problem number 2. So it says an airplane travels north with an airspeed of 300 miles an hour. There is a wind from the southwest at 50 miles per hour. What is the resulting course of the plane? Meaning, let's find magnitude and direction. So first we know we have 300 miles an hour and the airplane is traveling north. Okay, so what we're going to do is let's go on to this next problem. Let's do problem number 2 here. Oh, okay, well, that's fine. Problem number 2, and we have a plane headed north at 300 miles per hour. Okay, so what I'm going to do is actually I'm going to switch this over to graph paper here. Okay, so then I'm going to make my little graph. I'm going to put it over here, this way and this way. Okay, so we can think of this as north, east, south, and west. Okay, so let's use red for my plane. So it's going this way, right? And we know that is 300. So how much of that for the plane is what we need to do is let's figure this out in the x direction. And then let's also figure this out for the y direction. Okay, so how much of the plane is going in the x direction? Well, x direction means, if you think about the x direction, you can think of that as this is like west or east, and you can think of the y as north or south. Okay, so how much of this is going north or south? Well, the whole plane is only going north at 300, so we can say the y-coordinate of the plane is going to be 300, and the x-coordinate of the plane, is going to be 0, because it's not going any east or west. Okay, so there's our first vector. So we have everything kind of broken down into our x and y parts for that vector. Okay, so next we have the wind at southwest at 50 miles per hour. It's coming from the southwest. So to think about if it's coming from the southwest, that means it's going to the northeast. And when we say, here's a quick note, if it says southwest, that means it's a 45-degree angle. It's going from exactly halfway between south and west. So that means it should go through all of these points, right? So we should say, what I'm going to do is I'm going to draw this one a little bit shorter. So I'm going to say that one, and we said it was 50 miles per hour. Okay, 50 miles per hour. So what we could also say is maybe this right here, well, I could just slide this one up so it goes right here. So we have 50 miles per hour as our hypotenuse of a little right triangle. Okay, so normally what I would do is I would put it up here, head to tail, because that's how we add vectors. But I'm going to make this, I'm going to use one kind of like, I'm going to make up my own triangle to figure out what I'm going to do for the wind speed. All right, so we need wind x, and we also need wind y. And the east, west, north, south also work exactly the same for wind here and wind here. Okay, so what I'm going to do is actually I'm going to draw this right triangle all over again, and I'm going to draw it right here. That way we kind of don't have too much stuff going on. Okay, so I'm actually going to include this one right here as my y, and we'll make this one here my x. Okay, we know that my hypotenuse is 50, and we know this is a right angle. We know this is 45 degrees, and we know this one's 45 degrees. Okay, so what we're going to do is we need to find our x value, and we need to find our y value. Now, this x value and this y value match up with this x value and this y value right here. So if we can find those values, then we can just put them right in for the wind. Okay, so in order to find this x value, well, x is the adjacent side, and y is the opposite side. Okay, so if we want to find x first, we know x is the adjacent. We have the hypotenuse because we know 50 is the hypotenuse. Oops, okay. So we know 50 is a hypotenuse. So I have the hypotenuse, 50. I have the adjacent, x, and I have the angle 45. So if you remember which one uses adjacent and hypotenuse, we have ka, and we have so, and we have toa. So we're going to use ka to find out the x value, okay? So we can say cosine of 45 degrees equals x over 50. Okay, if I multiply both sides by 50, I get 50 times cosine of 45 degrees equals x. And if I go to Desmos right here, 50 times cosine of 45 degrees is 35.355 right there. Okay, so I can go right in and I can say 35.355 equals x. So that's how far the wind is traveling just in the x direction. So we can say that's 35.355. Okay, so now what we're going to do is I'm actually going to erase this because I'm going to use it again, but I'm keeping the sine part because SOH is opposite over hypotenuse, and I want to find the opposite, and I know the angle, and I know the hypotenuse, so I can do the same thing. Sine of 45 degrees equals y over 50. Okay, and notice this angle here is the same as this angle here. That's always going to be the case. So how you solve this one is going to be the exact same. Multiply by 50, and you get 50 sine of 45 degrees equals y. And because I know 45, 45, 90 triangle shortcuts, I know this one and this one are congruent because it's an isosceles triangle. So I know that y is also 35.355. So we get 35.355. Okay, so we had to do a little bit of extra work for those, for the wind to be able to find out the x and y parts, right? So now let's do the resultant. So the resultant x and the resultant y, well, the resultant x is going to be when I add those two together, right? Because the x values are going, because it's 0, but the x values are both going in the same direction. We could say the plane is going 0 to the right, and the wind is going 35.355 to the right, okay, or to the east. So we can just add those two together, and we can say that's going to be 35.355 plus 0. And then for the resultant y, I'm going to add these two together, right? Now I want to check to make sure they're going in the same direction. So the plane's going north, it's going up 30, and we know the wind vector is also going up by 35.355, this little spot right here. So we know they're both positive, so I can add them together, and I can get that is 35.355. I'm sorry, plus 300 is 335.355. Lots of 3's and lots of 5's. Okay, so now what we can do is what we just did with number 1. We need to draw this triangle. Okay, and it's going to be a right triangle, so I'm actually going to draw it in black here. We're going to say we went a little bit to the x, went a little bit this way, right? And then we went a lot up, 335. So we're getting, my drawing is definitely not to scale. I'm going to erase this black line because I don't need it. And what I'm going to do is, let's say our resultant is going to be just this purple, and it's going to be this right here. That's going to be our resultant. That's going to be our vector. Let's call it magnitude of v. Let's say our resultant is v. So I know my x is 35.355. And we know the y is 335.355. So first I'm going to find magnitude. Remember, that is just Pythagorean theorem. Yep. And my child here is getting really excited about doing the Pythagorean theorem. Can't you tell? So that is the square root of 35.355 squared plus, there we go, 335.355 squared. All right, so that's going to be the magnitude of v. So we can say that's going to be how fast is this plane going. There we go. And so we can say magnitude of v. I'm actually going to erase that and draw that again because that looks horrible. Let's try that again. Magnitude of v is, and I think I put it right on here. Yes, I did. It's the next line right here, 337.21. So we can say it's 337.21. Okay, and then what we want to do is we want to find this right here. That's our angle theta. That's the direction that we're looking at right there. Okay, so we can say we have the opposite, we have the adjacent. So the one that we want to use, again, is tangent, and we're always going to use tangent. I mean, I guess you could use this, but since we had to approximate, I would just use the two sides that we have. So we can say, I'm going to do the theta in black. So we can say tangent, and this is for direction. Tangent of theta is equal to opposite, which is 35.355, over the adjacent, which is 335.355. And then to find tangent, to find theta, we have to get rid of tangent. So we can say theta equals tangent inverse of 35.355 over 335.355. Whew. Okay, and if we do that, you should end up with this one right here, which is 6.01. 6.01. Okay, so that means theta is 6.01 degrees. Okay, so what does this all mean? Let's put it all together. We can say the plane is flying 337.21 miles per hour. And we knew it was flying north, right? And the wind was going northeast. So we can say this angle right here is really, we can say the plane is flying that. We're going to say it starts off facing north, and we're going to go 6.01 degrees east. So there's the answer for number 2. A lot of steps, but once you get the steps, it's kind of the same thing over and over and over again. All right, so see if you can do number 3.